All right, today we're talking about part 5 of section 1-1, and the topic is average rate of change over an interval. Now, in previous math classes, you may remember a term called slope. And slope is exactly what the average rate of change is. Now, slope and the average rate of change can be referred to in a couple different ways, one of which is a formula. The slope formula, you might remember from previous classes, is y2 minus y1 over x2 minus x1. And this is where we take the x and y coordinates of two endpoints and plug them into the formula. Slope is also often referred to as rise over run, where the rise is the vertical change from one point to another, and the run is the horizontal change from one point to another. This can also be referred to as the change in y over the change in x. Now, in this section 1-1, we've been looking at graphs the entire time. So for our purposes, we're going to focus on using slope, or the average rate of change, as rise over run. You certainly can use the slope formula, but you also can just look at the graph and see the rise over the run. So let's take a look at a couple examples. This is example 5 out of the book. What is the average rate of change over the intervals -2 to 0, 0 to 3, and -2 to 3? And they've given us a graph that's a horizontal line. So let's find the average rate of change over each of these intervals. The first interval will go from -2 to 0. Well, this goes from -2 to 0. Remember that an interval is the x-coordinates only. So we are looking at just this piece of the graph right here. Now let's look for the rise over the run. If we start from the point on the left and read the graph from left to right, what is the rise from point 1 to point 2? It's 0, right? We haven't gone up or down. So in this case, over the interval -2 to 0, the rise is 0. The run is 2 because we're moving 2 units to the right. But regardless of what the run is, 0 divided by any number is still going to be 0. So there's our average rate of change. Let's look at our second interval, from 0 to 3. So now we're looking from here, 1, 2, 3. We're looking at that interval of the graph. And again, we can see that there's been no rise. This time the run is 3, but still 0 divided by 3 is 0. So that's our average rate of change over that interval. The third interval goes from -2 all the way to 3. So now we're looking at that interval of the graph. Well, there's still not going to be any rise over this interval. The run will now be 1, 2, 3, 4, 5. But 0 divided by 5 is still 0. So what we can take away from this example is that anytime we have a horizontal line, we are going to have a constant slope, or average rate of change, of 0. All right, here's our next example. We're going to find the average rate of change over the same 3 intervals, but now we have a different graph. Let's start with the interval from -2 to 0. So here's the x value of -2, here's the x value of 0. So we're looking at the graph from here to here. What is the average rate of change? Well, This point corresponds to a y value of -2, and this point corresponds to a y value of -1. So we are rising 1, and we are running 2. So we're rising 1, sorry, I put -1, equals 1, and we're running 2. So we have an average rate of change of 1/2. The second interval is from 0 to 3. So now we're looking from here to here. Now this value is 0.5. It has a y value of 0.5. So we are rising 1.5, 1.5. And we're running, let's erase this. We're running from 0, 1, 2, 3. Now, 1.5 divided by 3 is 1/2. The third interval, -2, 3. So now we're going from here to here. Well, here's our rise. 1, 2.5. 2.5. And our run, 1, 2, 3, 4, 5. And 2.5 divided by 5, again, is 1/2. So what can we conclude from this example? Anytime we have a line that is not horizontal, we're going to have a constant slope. In this case, 1/2. All right, here's our last example. This time we have a parabola. We're going to find the average rates of change over the same 3 intervals that we've used in the last 2. So let's start with the first interval, -2 to 0. So we're going to go, here's -2, x equals -2. We're going to go to this point, and it has a y coordinate of 4, all the way to the x coordinate of 0, which also has a y coordinate of 0. So what is our rise over our run? Well, our rise is -4, because we're going down 1, 2, 3, 4. And our run is 1, 2. So the average rate of change of this first interval is -2. Our second interval goes from 0 to 3. Well, that's going to start here and go all the way over here. And this point has a y value of 9. So what's our rise over our run? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9 is our rise. And our run is 1, 2, 3. 9 over 3 is 3. The third interval, -2 to 3. Okay, so now we're going with this point. And this point. So this has a y value of 4. This has a y value of 9. So our rise is 5. 1, 2, 3, 4, 5. And our run is 1, 2, 3, 4, 5. 5 over 5 is 1. So there are the average rates of change over the 3 intervals. And the big takeaway from this example is that when you have a graph that is not linear, like a parabola, you will have different average rates of change over different intervals.